All right, here we go, guys. You guys ready? Okay. Note 10, derivative of trig functions. We're gonna go basic. We're gonna go simple. I think this is not a formal definition. This is just doing it with visuals. So I'm gonna call this red function y, and so y looks like that. And I'm gonna choose a different color for y prime. So I'm gonna say this color, sky blue, is y prime, my derivative. And look what it says here. It says, let's see if we can derive the derivative of a sine by looking at the tangent slopes and plotting their values. So we're just plotting tangent slopes, which is the derivative of y. Yay or nay? All right, so listen carefully. By the way, what graph is this? We all had pre-calc. This is the... It's not cosine. It's a sine graph. And maybe I should have put the radians instead of integers there. I just put this graph in Desmos and copy paste it, but I could have put it in radians and it probably would have. Anyways, here we go. Everywhere there's a point of inflection, the slope is either 1 or -1. All my points of inflection are going to happen at the midline, or they're going to happen on the x-axis. Cool or not cool? Okay, so I'm going to go ahead. I'm just going to draw a little. You know what? I'll just draw right on the curve. So that's a slope of 1 right there. Actually, you know, I said that this is going to be y prime, so I'm not going to put that. Let me put it in red. So this is a slope of 1, slope of -1, slope of 1, slope of -1, slope of 1. Wherever there's a point of inflection, which is right on the x-axis. And then where do I have 0 slopes? Where do I have a slope of 0 for my tangent lines? Yeah, so the word, it starts with the letter M at the second letter A. At the maximums and minimums. Yeah, so at the max and min. So look, notice that you have tangent slopes of 0 there. Take a different color, or a different colored pencil, or a different pen, or just anything, or just make it darker. I'm going to put those values. So what did I say? Wherever there's a point of inflection, the value is 1 or -1. So I'm starting at the left. So way over here, and I'm just going to go stroll up, and I'm going to put a point. That value is a 1. Notice that it says 1 right here, see? So I put a point. And then wherever I have a tangent slope, I put a point at the x-axis at 0. So just, does that make sense? Because I'm plotting y prime. So this slope is -1, so I go to -1 and I put a point, -1. I go to my 0 and I just go straight up and I put a point. Put a point. Put a point. Put a point. 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 And point. Are we okay so far? Nothing crazy, right? All I did was plot points, guys. Just plotted points. I'm either plotting a point at the y value of 1, at the y value of 0, or the y value of -1. Those are the only points you should have. Cool or not cool? Okay, I'm going to connect them. Obviously, it's going to be a wave. Wherever you have the points at 1, those are max. Wherever you have the points at -1, those are mins. I'm talking about the y values. And you should have a point of inflection on the x-axis. So that's where it changes concavity. So I'm going to go ahead and see if I can do little bowls here. Just kind of like when we were in our pre-cal days. Maybe. We'll see. I've drawn better graphs, but you know, that's fine for now. Let's see, Delgado, let's see. Oh yeah, that looks pretty good, miss. Way to go. Good job. Put it in the refrigerator. Yeah. I'm going to put that on your, when I write senior cards, I'm going to remind you guys.
I'm glad I learned it now.
I know exactly who had weird tangents. You had a weird tangent. Marchan had a weird tangent. Yeah. All right. Here we go. All right, guys. Focus, 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 focus. All right, here we go. So look at the red graph. Look at the sky blue graph. The red graph is your y. The sky blue graph is your derivative. What does the derivative look like? It looks like a cosine graph. So down here it says we can make the following statement. d dx of sine x is nothing more than cosine x. That's the same thing as saying y equals sine x. And if I take the derivative, I put a what on the y? A prime. And I just write cosine x. You can also have said dy dx. These are all different ways to say derivative. Cosine x. Okay, almost. So the derivative of sine x from now on is what? Okay, what's the derivative of sine x? What's the derivative of sine x? Okay, now you say it to yourselves. The derivative of sine x is cosine x. Say it one more time. The derivative of sine x is cosine x. One more time. Let the Lord hear. The derivative of sine x is cosine x. Hallelujah. Okay. All right. Here we go. I hope he heard. I think he heard. Okay, here we go. Well, we don't know if Lord's a man or a woman. It could be a woman too, so, or maybe genderless or something. Okay, here we go. Here we go. Here we go. So, what do you think the derivative of cosine x is? Okay, well, Guerrero just guessed that a little while ago, and I told her, nah. It is sine x, but not just sine x. No. Put something in the front of it. Starts with the letter N. This is informal. We've actually done the proof of this, but you didn't know it was called derivative at the time. Do you want to see the proof? It doesn't matter to me. It might take about 5 minutes, but it's up to you guys. No? Okay. It's nice to see, but no. All right. Well, maybe later on we'll do it like after school for fun or something. Okay. Oh, you know what? I kind of want to do it actually now that we're talking about it. No? Okay. All right. All right. Someone remind me later on. But if you wanted to know the derivative, so don't worry. I'm just gonna write it down a little bit real quick. If you wanted to know the derivative of sine x, so I would have. If you want to see it the long way, here's how you do it the long way, guys. Don't worry, we're not gonna do it. We've done it before. You actually did it in your UH quiz when you were doing limits. Limit as h approaches 0 of sine parenthesis x plus h minus sine of x all over h. Do you guys remember doing that one? Yeah, we did it on the quiz that you guys got 100 in on question 10. And then we did it also in the notes. Yeah, trig 5. Yeah. So remember if you want to try it for fun, remember the secret is you got to remember what sine of a plus b is, which you guys remember? Sine A cosine B plus or minus? Plus. Yeah. Sine A cosine B plus cosine A sine B. Yeah. Yeah, you can say sine B cosine A if you want to. That's fine. All right. Cool or not cool? Okay. Oh, okay. If you wanted to do the derivative of the other one, you have to know cosine A plus B, which is cosine A cosine B minus sine A sine B. Okay, yeah, there was. All right, so here we go, guys. So I even put it in here. Simply put, the derivative of sine is the cosine, so here it is. I didn't do this fancy border. Obviously, I took this notation from some textbook. It was a Demana book, if you're curious, the 3rd edition. If you want a formal proof using limits, let me know. We can derive the proof from scratch. Here we go. The derivative of cosine x is? Negative sine. So you guys already know the product rule. All right, guys, focus, focus. I know it's Friday, but we got to continue here. All right, y prime equals. I can't just take a derivative. So the most common mistake that you guys do here you guys just go 2x cosine x. Can I do that? No, you got to use what rule? Product. To help you out, the x squared is the first, and the sine x is the second. Can someone help me out and tell me what the product rule is? So what is it? First, so, which is what? Plus or minus? Plus. There it is. First times the root of the second plus second times the root of the first. If you do it the delta way, they just reverse the order. That's not a big deal. It's the same thing because there's a plus in the middle. Be careful. The quotient rule is not the same. You can't. So just be careful with the quotient rule. All right, y prime. I'm going to write it pretty. Usually you just put the two x's in front of the trig here. So x squared cosine x. There's my product. Plus 2x sine x. A common mistake. You guys multiply by the argument all the time. I've never understood. When I say argument, I mean what's inside the cosine and the sine. You can't touch that. Whatever the argument is, leave it alone. It does not turn from sine x to sine of 2x squared. You cannot do that. That x, so that argument is like saying f of x. You can't go f times 2, oh, that's f of 2x. No, that's not how it works. That 2 goes in the front. So stop doing that. Don't do that. I don't know where you got that from. No one ever taught you that. Yeah. So don't do that. Cool or not cool? Okay. How do we feel? All right. Let's continue. Look at letter B. I am using the what rule? Quotient. It has the letter U instead of Y. So I'm going to go ahead and use the du dx. I'm taking the derivative of u, so I'm going to write du over dx. Is everyone okay with that? Yes, you could write u prime. But I need to get you guys used to all types of terminology, all types of symbols. Because this is an expression of u, but with respect to what letter? X. So I wrote du dx. Cool or not cool? Equals, tell me, what do I put first? Low. So I write times, which is, what's the derivative of the top? Yes. Charles, how did you memorize that so fast? The way I do it, I'm not telling you guys how to do it, but the way I do it, okay, I'll just tell you a secret already. If it's a trig and it starts with the letter C, it's going to be a negative. So later on, when we start learning more advanced ones, if it starts with the letter C and you're taking a derivative, it's going to be a negative. So all right, you'll see right now when we do cotangent. Bottom times rid of the top, and then plus or minus? Minus top times derivative of the bottom. So the derivative of the bottom is just yeah, but yeah, it's not negative because of sign, but it's negative because I have a minus in the front. Are we okay? Yes. There's a negative in the front.
Yeah, but because the one doesn't derivative. Yeah. Like I know that goes worse. So you look at the thing and derivative of sine x is cosine x with the negative.
All right, get it already? Look. What's the derivative of negative x squared? Yeah, you just keep the negative in the front. The derivative of x squared is 2x, so you just put the negative.
I just got mixed up.
So, that's a side note. All right, over, we're not done. Over what? Perfect. Are we okay? All right, let's not leave it like that. Let's see what happens. You're done. That's the only calculus there is here. The rest is just algebra, and I guess because we're working with trig, pre-cal. So here we go, distribute. So I'm going to write equals negative sine x. Negative times the negative is a plus sine square x. And then again, negative times the negative is a. Why'd you say it like that? I'm not the only one that heard that, right? You know what I'm talking about. Positive? You must be from New York. I'll stop. Sorry, miss. Everyone bully. No, YouTube. I do not bully my kids, except Alvarez. But that's an exception. Ask, Ian. Yeah, we're good, right, Alvarez? No, ask. Okay. All right, here we go. Ready? There should be a red flag popping in your head right now. Look at the numerator.
It's one.
It's 1. What's 1?
The sine squared x plus cosine squared.
Oh, you guys must have a good pre-cal teacher. Well, you guys knew that. That's crazy. Yes. Notice that the factor in the numerator and the factor in the denominator, they look like they could be the same. They are the same. Do you guys notice that? So, let me rewrite it so you guys can see it. And what's going to cancel out? Correct. One of these. Now, some of you have a habit of canceling and then just writing 1 minus sine x and saying that's the answer. Notice that 1 minus sine x is at the bottom. It's in the denominator, so it stays in the denominator. It doesn't just magically move up. So to show that it's in the bottom, you put 1 over 1 minus sine x, just like Lavelle said. Cool or not cool? Yeah, so stop making that mistake of just writing 1 minus sine x. Way to go, Lavelle. Yay or nay? Okay, here we go. Go to the next one. So now I want to know the derivative of tan x. We're not going to do it with pictures. This one, we're going to say, well, I know I'm going to keep writing d dx. I know that tan x is just what over what from pre-cal? I'm going to write equals. I'm no longer going to write d dx. What rule do I got to use for sine x over cosine x? The quotient rule. We already know the derivative of sine. We already know the derivative of cosine, so you have all the skills necessary for this. So let's use our definition. What do I write? Perfect. Bottom, cosine x. I like to use parentheses right from the get-go. Get in that habit of that. Times what? Times the derivative of the top, which is plus or minus? Minus top, so sine x, times. Am I done? All this is over. They catch up to here. Are we still all right? All right, here we go. I'm going to put the equal sign, meaning I'm still continuing. What is cosine x times cosine x? What is negative sine x times negative sine x? Again, the Valentine's formula comes out. Don't call it that at the university. Well, if you're talking to a professor, don't call it that. It's not called a Valentine's formula. It's a trig identity. A trig Pythagorean identity.
Why'd you make it cosine squared?
Because that's what this is. That's the two. Oh, side note. Cosine squared x like that means it's cosine x being squared. So make sure you know that. That's a common mistake. Cosine with the x squared is the x is the argument. That's what. Let me remove that squared here from the cosine. That is this. So make sure you know the difference. If you just put a square after the x, it's the x that's being squared, not the cosine. Yeah, I told you guys in pre-cal all the time that. All right, here we go. Cosine squared plus sine squared is equal to what? So 1 over cosine squared x. And you could leave it like that, but no one does because 1 over cosine is the same thing as secant. So because I have a square in the bottom, I have to say what? Secant squared. So from now on, are you going to have to do this all the time for tan x, for the derivative of tan x? No. I mean, you could. You could. No one's stopping you. It's a free country. It's America. But it's probably a lot faster if you just memorize that the derivative of tan is secant squared. Cool or not cool? Cool. All right, so here's what okay, before I continue with that, here's what I want you to do. Well, you know what? Before we do this next example, I just put this example in next, but there are a few formulas you're going to have to memorize. You already know sine. What's the derivative of sine? Cosine. Now, okay, I wouldn't call this a pet peeve, but it's definitely wrong, and I've seen it on the reading, and every time they do that, we just go, shoot. If it's relevant to the problem, they lose a point. If you say this, oh yeah, child, the derivative of sine x is cosine. You did not illustrate to me that you said the derivative of sine x. You're just telling me sine x equals cosine. That is x equals pi over 4, comma, 7 pi over 4, right? Because cosine and sine are the same at pi over 4. That's what you're telling me here. If you want to tell me that the derivative of sine x is cosine, you got to use calculus notation and put that in parentheses and say d dx. So that means the derivative of sine x is cosine. Don't be writing, oh, and by the way, you need an argument. Some of you will write sine x and you'll just say, oh yeah, that. Guys, it has to have something. It can't just be sine. You got to write x. Yeah, because some of you guys will tell me this. Maybe you'll write d dx and then you'll write sine and then you just say, oh, that's just cosine. You need an argument. It can't just be by itself. Cool or not cool? Okay. What else? Okay, so here we go. I'm going to tell you guys which ones you have to memorize. So you already know, and don't worry, it is in your notes, but I like to write them down so you guys can also memorize it. You already know these, so know these. Derivative of sine x, what is it? Cosine x, so let's rewrite it again so we can get it in our brains. d dx of cosine x is negative sine x, and then we know now d dx of tan x, and we know that one is now what? Okay. There's one more that you got to memorize. d dx of secant x. So the derivative of this one, doesn't come natural, is secant x tan x. We can derive that one too, if you want to. Let me know and we'll do it. Maybe we should. I don't know. You guys want to? Okay. From those, you should be able to figure out, and we're not robots, but yeah, I mean, like I said, it does help to memorize. It'll make life a lot easier if you just memorize these. All right, from those, d dx of cotangent x. Remember I told you that everything that starts with a c is negative? So the derivative of cotangent, put a negative, and tangent is the reciprocal, cotangent is the reciprocal of tangent. So what's the reciprocal of secant? Well, yeah, cosine. And then sine is the reciprocal of cosecant. So what's the other? Secant's the reciprocal of cosine. What's the other one? Well, cotangent is the reciprocal of tangent, but the secant and cosecant. Yeah, I did a bad job on that. Let me. Yeah. I just saw you right. Yeah, I was so bad at that. Let's start again. Okay. Yeah, just go ahead and just write cosecant x. Cosecant squared x. I did such a bad job. Let's start again. Ready? Pretend none of that happened. All right. Yeah, you weren't listening. All right. The derivative of tangent is secant squared, right? Cotangent is the reciprocal of tangent, right? So what I meant to say is, we know that secant's the reciprocal of cosine, and then we know that cosecant's the reciprocal of sine. So notice I used tan, so if I'm using cotangent, they're all related. Which one's the other one that I haven't used? Besides cotangent, I have the other reciprocal function I haven't used is the cosecant. Keep the squares, they're related, and we can derive them. Yeah, maybe I'm doing such a horrible job here. Here, it may look better after I do this one. Secant x, so maybe I do cosecant x, and then I write cosecant x, negative cosecant x, cotangent x. Okay, they're all related. So I think I agree with you guys that I did a bad job. Know these. Know these four. What's the derivative of tan x? Secant squared. What's the derivative of secant x? Okay, now here's what I tried to do, but I failed miserably, epically. Tan x and cotangent x are related. They're reciprocals of each other. So we got to use, the patterns are similar, but we have to use reciprocal functions that we haven't used yet. So if I've already used a secant, the other one that I haven't used is a cosecant. And the cotangent, we're not going to use it because that doesn't make any sense, right? I'm taking the derivative of cotangent. So the derivative of cotangent is negative cosecant squared. So look, what's the derivative of tangent? Secant squared. What's the derivative of cotangent? Negative cosecant squared. What's the derivative of secant x? Secant x tan x. What's the derivative of cosecant x? Negative cosecant x cotangent x. See how they're kind of related? But I did a bad job of explaining it the first time. But hopefully now it's making sense. So look, let's do it again. Derivative of sine, cosine. Derivative of cosine, negative sign. Derivative of tan, secant squared. Derivative of secant x. Perfect. Derivative of cotangent x. So before you answer, you go, well, the derivative of tan is secant squared. So the derivative of cotangent must be, it starts with a c, negative, and let's see, here we use secant. Oh, it has to be the cosecant one. Negative cosecant squared. Boom. Do you see that? Derivative of secant is secant x tan x. So the derivative of cosecant is a negative cosecant x cotangent x. Notice that the secant has a secant in it. So secant x tan x. Notice that the cosecant has a cosecant in it. Cosecant x, and you can't use the tan, it has to be the other one, cotangent x. So now you're starting to see how they're kind of related? Yeah. So these, the ones that I blocked, memorize those. And then when you're doing cotangent and cosecant, like, oh, okay, they're similar. Hold on, the derivative of tan is secant squared, so the derivative of cotangent must be negative cosecant squared, because everything that starts with a c is a negative. The derivative of cosecant x, well, I know the derivative of secant x, that's secant x tan x, so the derivative of cosecant x must be, well, let's see, negative, or it has to be itself, cosecant x, and then let's see, the other one is, oh, cotangent. Boom. Cool or not cool? Yeah, I know. It's hard in the beginning, guys. All right, so check it out. Look at this. This is coming from UH, and I'm going to go slow. I want the derivative of that. G prime of x equals, what's the derivative of x? Oh, man, we forgot. 1, just 1. Plus, all right, so sometimes we have a fight here in the beginning. You could, all right. Yeah, sometimes. I mean, not a real fight. Not a real fight. Unless you want to, no. Okay. No. The derivative of 2 cosine x is? Yes, good job. You guys did it right off the bat. How come you didn't do product rule? Well, plus, and then the derivative of cosine is negative, so negative 2. Well, I already put plus, too bad. All right. Sometimes some of you fight me and say, well, that's a product, Chavez. And then I'm like, yes, but that 2 does not have a variable in it. So I can just attach that 2 with that cosine. But if you're adamant about using product rule, let's say you're like, I want to use product rule. Look at this. I'm just going to come up here to the top. DDS, don't write this down, just listen. Or you can write it down if you want. First, second, check it out. First, 2, the derivative of cosine, negative sine x, plus second, cosine x. And derivative of the first, what's the derivative of 2? 0. Anything times 0 is itself. Look, negative 2 sine x. Cool or not cool? Yeah, you guys didn't puffer. You guys got the answer right off the bat. What's the derivative of cotangent x?
Negative cosine squared x.
Perfect. Here comes pre-cal. You're done with calculus. That was it. Here comes pre-cal, and it's not heavy pre-cal. It's not heavy pre-cal, guys. G prime of pi over 4 equals 1 minus 2. There's your minus, Guerrero. What is sine of pi over 4? You know what? I'll write sine pi over 4 first.
Square root of 2 over 2.
Yes, it is. Okay, here we go. G prime of pi over 4. 1 minus 2 times square root of 2 over 2. What is cosecant of pi over 4? Cosecant's a reciprocal of sine. Well, pi over 4 doesn't matter because both cosine and sine are the same. What's the reciprocal of square root of 2 over 2? Yes, but just give me 2 over. That's a reciprocal, right?
That bothers me.
Okay. Put the square. Is anyone shocked? Yeah, it's just pre-cal, guys. The algebra is the hardest part. All right, there's my reciprocal. If you want to write square root of 2, go ahead. Just put cosecant of pi over 4 square root of 2. No big deal. All right, here we go. All you're doing is analyzing. These 2's cancel out. And then here's what you get. 1 minus square root of 2. That's this guy. Minus, when I square the 2, 2 squared is 4. And square root of 2 is 2. Is everyone okay with that? 4 over 2 is the same thing as 2. So what's 1 minus 2? Negative 1. So here we go. Negative square root of 2 minus 1. Is that answer in here? Yeah, I did too. I did 3. Thought you were talking to me in Spanish. Are we okay? Vanessa, we're all right? Okay. All right. Here we go. Look, here are those derivatives that we just told you about. Chav, how am I going to memorize all those? Just memorize these 2. And if you memorize those 2, you actually by accident know the other 2. Yes. Look, what's the derivative of tan x? No. Secant what? Say it, guys. Okay, what's the derivative of secant x? Yeah, secant x tan x. What's the derivative of cotangent x? What's the derivative of cosecant x? Okay, good. All right. Do you guys have your calculator? Okay, everyone have the calculator. All right. Find an equation for the lines that are tangent and normal to the graph of f of x equals tan x over x at x equals 2. We're not going to do quotient rule. We're just going to tell the calculator right off the bat to give us a point. I need 2 things for a tangent line. What and what? All right, let's get the point first. F of 2. Here it is. I'm going to take my calculator. So, you guys okay, guys? Are you guys mad? Okay, I'm going to take my calculator. Focus, focus, focus. And I'm going to write tan 2 over 2. So, I'm going to push tan 2 divided by 2, like that. And you should get that number. You could also use the fraction feature. Sorry. Alpha y equals, and you can go numerator, denominator, tan 2 over 2, and it should be the same. There it is. Are we okay? Okay, let's use always, 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 unless otherwise told, at least 3 digits after the decimal. I'm going to put the first 4. The more, the better. Negative 1.0925. Negative 1.0925. So here's my point. 2 comma negative 1.0925. And I know y'all, no Yanimus. Trying to be sneaky over there. Hey, Marchan, no. Man, Guerrero, stop. Man, the next one's going right to Montolongo's office. All right. All right, here we go. I also need a what? A slope. Here we go. F prime of 2 equals, and I'm going to show you how to do the derivative in the calculator. You guys ready? Push the math button. I saw you, Lavelle. Man, you guys are... Number 8. Focus, guys. Focus. Number 8. Numerical derivative. Push enter. Look at all this. Relax. It's going to go D, and then you're going to put a what in here? X. The X is next to the alpha. And then you put what you want to find a derivative of. I'm going to put the fraction feature. So I'm going to write tan x in the top. Tan x over. Don't put the number 2 in there, because then that's a derivative of a constant, and derivative of a constant is 0. Look at me putting a 2 there. Tan x over x, because that was the function, right? Tan x over x. And then here, what do you think you're going to put in there? 2. So this is telling me that I'm taking the derivative of tan x over x at x equals 2. And there it is, 3.4334 truncated, or 4335 rounded. 3.4335. 3.4335. I'm okay. All right. Are we okay? All right. I want to see, okay, so here's the tangent line, guys. I'm going to write my tangent line. Y minus, so it turns to a positive, 1.0925 equals, what's my slope? 3.43. X minus 2. Leave it alone. Let's see how this looks on Desmos. I know you can just as easily type it into your calculator, but I'm going to use Desmos because that graph is nice and pretty. All right, here we go. Desmos, graphing calculator. All right. Here it is, guys. Focus, focus, focus. Y equals tan x. Here are your functions right here. So tan x, and all this is divided by what? So there it is. Now let's see how this tangent line looks. All right, guys. 2 comma, what was my y value? Point. So there's my point right there. So my tangent line should have a positive slope. It does. All right, so here it goes. Y plus 1.0925 equals
3.4335 x minus 2.
And look at that beautiful graph.
That's crazy.
Cool or not cool, guys?
I see the tangent line.
Yeah, do you see the tangent line? Okay. Okay, I'm glad you see the tangent. All right, here we go. Example 4. This is the last example, guys.
Prime.
What does y prime prime mean? All right, guys, focus, 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 focus. Second derivative. So here we go. Y prime equals, what's the derivative of secant x?
Secant x tan x.
So write that down. Am I done? No. What rule do I got to use to find y prime prime? Product. Do you guys see that? Underline to help you out so you can know what's first and what's second. Right, Flores? Right. So here we go. You guys help me out. What do I write first? Use parentheses.
Oh, I wrote something really.
What's the derivative of the second? So first times derivative of the second. What do I write next? Second times derivative of the first, which is what? All right, let's see what this is. Y prime prime equals secant x times secant squared is? And then I see that I have 2 tan x's, but it's a product. So I'm going to write the secant x first, and I'm going to write tan what? Tan squared x, with the squared after the n. And there it is. Sometimes they want it in factored form. Sometimes this is perfectly fine.